version control, git, and the repository URL will be, I'll use the HTTP protocol. So it will be this one. I am going ahead and put it in the chat. Most of you should have it from the Git training. And I'm just gonna put it under my home directory, Git, DSPG 2020. That's where I'm going to save that repository. Everyone good so far? File, new project, version control, Git. I get up to here. I paste that. I can use tab to get the autocomplete. Basically, we'll just name it whatever the repo name is. And then I select where I want to clone it to. So here I'm just cloning it under Git. And then I just have a folder here, DSPG 2020, but you can just keep it under Git. And I'm just gonna go ahead and click create project. And it says complain because I already have it, which is right here. And you should have something. Oh, wait, I actually deleted that. Yes. I'll just do it with you all. File, version control, git, clone that with the same URL that I posted in the chat. I'm gonna save it here. And I click create project. What this is doing is it's basically the same as git cloning, just with a GUI. Then if you have the training repo clone down, activate DR project for those that have it already from the previous training. And you should have something like this. If you already had it, just make sure that you can pull to get the latest. So you can just click git pull, and it will download whatever changes have been pushed since you last cloned it. And then here, I wanna make sure that everyone is up here. So if everyone can just do yes or hands up, thumbs up, or yes, just to make sure that everyone is good up to this point. Okay, I see 14, 15, 16, perfect. That's good. Okay, if you're having an issue, do a no, just to know, to make sure that we're not leaving anyone. Okay. The people in the chat, if y'all can reach out to the people that have stated that they have an issue. I think you can't have an issue. Okay. Okay, perfect. Yeah, cloning will take a little bit. You don't have to worry about. So the first thing that we're gonna do with RStudio is we're going to customize it, because RStudio is an IDE. That means that it's an integrated development environment. That means that it's supposed to enhance your productivity. And we need to be comfortable with tool. So if you go to tools, global options, you will get something like this. We have some people mentioned it last time, where they can customize it. Yes, you can customize it. So usually what I do is I keep the defaults for most of these. I don't like to save or be prompt to ask whether I want to save my R data on exit. So I put that to never. For the code, especially for those that are starting to learn R, I would suggest that you click most of them. So for example, let's see, there we go. In diagnostics, it's a good strategy to click on those because it will help you while you're learning R to catch any mistakes that you might be doing in terms of the syntax, or maybe you forgot a variable, or you're using or you're not using some variable that you defined. So these are some heuristics that will help you catch those errors. So I suggest you turn those on. I like to fold my code. So I have start and end. For saving, I encourage everyone to just have the source end with new line. They'll make sure that when you're saving files and pushing to Git, Git won't complain that the file doesn't end with a new line. Same for completion. We want like everything that can help us to understand develop the code. So in diagnostics, show diagnostics for R, check arguments for our function calls, basically everything that can help you be more productive. Okay. Any questions so far? Good. We also care about appearance. So if you have a hard time reading the code or the font size, do increase the font size. We want to be able to see and don't put too much stress in your eyesight. So for example, I keep it at 10. I have my glasses on, but if you need that font a little bigger, make sure that you put it so it's a bit more comfortable. And all of this is available. Oh no, or yeah, we're recording. So everything will be available for you to go back. And for the editor theme, I like Tomorrow Night 80s. It's a dark theme. So feel free to choose one if it puts less strain in your eyesight. Okay. So hopefully with that, we gave enough time for folks to clone the repository. Oh, just to make sure, again, I went to tools and then I went to global options. Basically, I just went through each tab and under each tab, each sub-tab, and I decided, oh, do I want to select or highlight the selected line? Yes. Do I want to show a margin? And then I can customize it to the margin, like how many characters. You want to highlight the syntax, our function calls. Do I want to call full style? And we'll go over some of those, but the idea is for you to be comfortable. The diagnostics are there to help you not make mistakes, or even if you're distracted, oh no, like I defined this variable, but I'm not using it. Or I'm using a function variable that hasn't been defined based on some heuristics. So that's just to help you while you're coding to identify stuff, because the last section of this training will be with debugging. So these are just ways to help you be more productive. Okay. So today we'll be going over our basics. That's folder 05_r-basics. So I'm just going to click on that. And I'm going to go to the 00 intro to R. I click on that one. Then I'm going to click on the HTML for that one, collection to R. And I'm going to view it in the web browser. Okay. Let's see the chat. If you don't have any folders inside your training, any folders in your train folder, make sure that while you're here, training, I activated the R project, and I will go over that in a second. And you should get a Git tab, and you can click pull. Basically, that just means make my local version of the repository match all the changes that have been pushed to the remote, which is the one on GitHub. So before every training, you should git pull like that. Or in the command line, if you're in terminal, yeah, you can do git status and then a git pull. And then you should have all the folders here. Can someone in the chat help those that don't have any folders? Yeah, someone from the chat should have that. Okay. So did everyone do new project, version control, Git, and then for the repo, it's this one here. I am going to copy it again. Make sure that you have the right repository. Then create project. Okay. And it's the same repository that we have been using for the Git. Perfect. Right. So I'm gonna go first, and every time that we have a repository that uses R, it's good practice to have an R project. And an R project is just a file that contains some heuristics and sets up an environment for that project. So in many computing programming languages, we want to have an environment that's reproducible. That means that we have all the dependencies and preferences. So it's the same pipeline or same behavior across different systems. So if I click on the R project, you'll see that has some defaults and some preferences. But one other thing that it does is once you open that project, RStudio will know where the working directory is. So when you're working with your projects, make sure that you click and open that project. So you will see it here in RStudio, where you have open project. You can click on that file, and you have the ones that you have accessed recently. Okay. And it will give you the Git tab, which has basically a GUI for pulling. Okay, it gives you like the master branch and all that. Okay, so I'm gonna go to R basics. And again, I'm going to R basics, intro to R, introduction to R, HTML. And I'm going to view it in the web browser first. Someone from the chat can help those that don't have any folders. Page isn't working. Can you explain what you mean by the page isn't working? Is it when you're opening the HTML file, or you can unmute yourself or put it in the chat?
Yeah, I'm sorry. Yes, just when I'm opening the HTML file, it says it pops up a page that says page is not working.
Well, that's not required right now, so we can troubleshoot that if it becomes a problem. Right now, I'm just gonna go and walk through that, and then we'll go back for the actual exercises. So, what is Sonar Markdown? This is a quote by Donald about what is literary programming. So literary programming is a way for, especially for data science, where you have the code, but you're also describing what the task is and giving some context, like good software. So the quote is basically, programs are meant to be read by humans and only incidentally for computers to execute, right? So that means that, same for like naming and whatnot, we want your work to be readable not only by the computers, but also by your team members and other people. So on our Markdown file is a mix of markup language, in this case, Markdown, and a programming language, in this case, R. Okay. So you can do stuff like bold italics, hyperlinks, other basically ways to customize the text. So for example, this is a H2, if I'm not mistaken, HTML, that would be 2 pound signs in Markdown. Same for list and whatnot. I'll show the code in a little bit. So as I mentioned, we first want to customize your studio so you can be as productive as you can. Second part is we're going to set up a few things in Ribana. so that they will work in the future for other projects and lessons. So what I'm going to show is your profile file. That's basically a startup file for R. And what that does is you can customize it to run code that you want to execute when R starts a session. So in this case, you can just copy the code after the lesson and modify it as you want. But what we'll be doing is in your home directory, you can create a file called .rprofile and copy these lines here, which are in the repository. What this does is an example that I'm gonna show what it means, and you will be able to read it and understand it and work with it by the end of today, hopefully. So I am using something called control flow. That means that I am indicating how or how many times or under what conditions some code should be executed. So this is what it's called a for loop. That means that it's going to execute the code for each of the arguments given in some iterable. So here, what it's doing is reading the lines in that file. And for each of the lines, it's going to execute this code, okay? If it's a kind of control flow where it's a conditional, so only execute this code up to here if this condition is true. And this is going to evaluate to a Boolean. So here in the condition is, does the line start with export? That's what it's testing. If that happens, then you're going to execute the code. In here, this is a variable assignment. That means that it's going to take the value in the right-hand side and it's going to assign it to a variable which is on the left-hand side. So sub means that it's going to substitute something with this pattern, and this is using regex. This is regular expressions, which you will have an entire lesson on that. It's going to replace the first instance of that with this. In this case, it's just eliminating or removing that. Likewise, we have another example of a conditional here, where this is basically going to return true if it matches this pattern in that text or in the, nice. It's going to negate that. So the exclamation mark means negate. So once we talk about the Booleans, it's going to flip the value for that Boolean. So basically it means if that pattern does not occur in X, then it's going to execute that, which is just a not replacement. And lastly, we're constructing or concatenating text. And then we are going to generate an expression based on that. And we're going to evaluate that. Okay. And this is what for citing or previewing what you will learn by the end of this. I'll go over data types in a second. So this is remove everything up to this point. So what I'm doing here is you will see an environment here. And this is where you have all your variables. For example, if I do X equals the integer 1, that's a value and it's going to show up here. I can remove that with the remove function. Likewise, I have a try expression, and that's going to be covered by the end of the session as well, where how do we handle errors? And here, what I'm just doing is creating or printing a function cookie. And lastly, I like to have a message welcoming to another session. So for example, when I started R, when you start R, you should be getting something like this. It has the R version, the copyright, the platform, some little brief about R, etc. But I also get quotes from some piece of R fortune, or basically funny or snitty comments from the R forums. For example, this one is by Bates, by Doug, who is responding to all about some questions, basically a little toxic environment, but that's so people know how to avoid that. And here, after that, I have Dr. Nasfreakin is GitHub. It tells me the time that I logged in. I'm currently quarantining in Puerto Rico, so I just have the time there as well. And you can just copy that command and customize it as you want. But to understand all of this, that's the purpose of our lesson today. So first off, we're going to learn how to load code. Code loading means that we're going to import or make accessible a namespace and functionality that's defined by, like, in some other environment. For example, if there is a package, in this case, we're going to be using the tidyverse and lubricate package. And the command to load those is library. So by using library and then passing a package, you will be making accessible the functionality that's exported from that package. For example, functions or data that's being provided by that package. Tidyverse likes to give you a brief on like all the packages that's loading and the versions, all that. I don't want to read it because I already know which version I'm using. So I just pass the invisible suppress package startup. But basically, you can just use library and then the package. And that way you can load that functionality. You don't, every time that you see a parentheses and then something after, that's a function call. So a function is a collection of methods that, depending on the type that you pass, it will execute some command where you can change the arguments. So here, this is a name argument that's called package. And it's also positional just like the first one. And I'm passing tidyverse. That means that it will execute the library method for a package. And then it will basically allow me to use the functionality in tidyverse. Okay. So we first are going to go over data types. Well, I have something in the chat. So how does invisible represent? Basically, if you were to just run that code, what it will return, and every function returns something. It can be the null or nothing, basically. So if I didn't put the invisible, it would just return a null. And I thought it was ugly in the markdown, so I just put invisible. You don't need it, but basically what it's saying is this function does return something. It just returns nothing or the null. And I will go over null in a little bit. So we have atomic data types. Atomic data types are the core data types in the art language, and everything else is usually a composite or some combination of those types. So we have logical, integer, numeric, complex, character, and raw. Raw, we're not going to talk about because you probably don't need it, but basically it's working at the bit level. But we'll be focusing on these, on the first 5. So the first one is logical. And that's what I was referring to Boolean. Oh. Yes, absolutely. And we'll go over that afterwards. Well, not for this one, but in the further ones when we start working more with our markdowns. So for the logical here, DC means that it's going to concatenate, or basically it's going to make a vector. And this is a name vector because I'm passing some quoted expression and then a value. I'm assigning these to X. So X is going to be a name vector where you have basically the different names and then values. And these are all Boolean. Boolean means that basically you're true or false. And in the case of R, NA, which is not available or not, basically. And what I'll do here is I'll go over some basic logic. If you remember from your math classes or computer, So we'll just go over some review of logic. So in R, if you have true and true, that returns true. If you have true and false, that returns false. And if you have true and NA, it will give you an A. Basically, when it can obviously know what the value is, it will give you an NA. Because, for example, if NA could potentially represent a true, then that would be true, but it could also represent a false, and that could be a false. Therefore, this is not known, basically. So it will carry on or propagate the uncertainty. For false, we know that it will always be false, right? And this is the AND operator. So that means that it will apply the AND logic. The next one is the OR, which is a pipe. So if it is true on one end, it will always be true. If it is false, it could be any of the values because it depends completely on the other. So this is the OR operator. We have the XOR. That one, how it works is basically you have to have different values. So if you have true and true, that's going to be false. True and false, these two are different, so that will be a true. And then here it's undefined because you don't know whether this is true, which in case it would be false, or it would be false and it would be true. Right? We can also negate values. So if you have a true, it can become false with the negation. Likewise with false. And if you negate an A, since it doesn't know what the value should be or it is, then it will just give you an A to propagate the uncertainty. R is kind of weird in the sense that it has a flexible and dangerous interpretation of numeric and booleans. So if you have a true and a 0, that will be false. But if you have a false or a -2, that will be a true, because everything that's not a 0 is interpreted to be true. Everything that is a 0, then it's false. Okay. Any questions so far on booleans? All right. Now we can go to integers. Integers are defined by a number and an L. Why? No idea. So here, what I'm doing is I'm defining two variables, x, which is going to be 2, and y, which is going to be 3. So we have positive signs, we have negative signs. We have operations like absolute value. We can add them up, we can subtract, we can multiply, we can divide. So if you divide two integers, what you get is a numeric. We can power the other. We can take the square root. Again, it will give you a numeric instead of an integer. We can take the modulus operand operator. We can make integer division. We can take the log, and we can take the exponent, and take the factorial. So basically, I hope this is pretty standard in terms of math for integers. So far, so good. Okay. Numerics are similar to integers. You can have the standard operators. You can add them, subtract, multiply, divide, power, square, modulus, integer division, log, which in this case defaults to base of e, which is another log, exponent, factorial. You can also round. So here, what I'm doing is I'm passing another argument to the function. If I don't pass any, it will use the default value unless it's required. Then it will give you an error. So this is the way that you can override default values in a function. And I should say that, well, square root of a numeric and a square root of an integer might look the same. They're not the same method. There's the same function, but depending on the type, different code will be executed. depending on the data type of the first argument in R, because it will use single dispatch. Okay. Factorial, round, floor, which is from down, and ceiling, which is from up. Same thing for complex numbers. I'll just breeze through these. And you can also have comparisons. So you can, for example, compare one value to the other. One caveat here is if you're using numeric types or complex, you should probably not use the equal or equal operator. You should be doing the approximate because these are using floating numbers, which are not precise or to arbitrary precision. So you should probably be using the it's complex. Do numeric and complex have L? No, only the L is used to basically force or declare that the number is an integer. Otherwise, it will default to be using numeric, unless you pass the imaginary part. So you can query whether it's complex, you can take the real part, the imaginary part, model, you can get the argument, the conjugate, etc. Basic operations in math for those. Next, I'll go over character. Sometimes it's called text in other languages or strings. What is the value of declaring a number as an integer as opposed to numeric? Good question. So they are different side effects. Good code should be able to handle it if the user specifies it as any. But sometimes you want to make sure. Sometimes you can have a function that works differently for integers than it does for numeric. For example, if I say I want to take a number that's already an integer, well, that doesn't make sense. Maybe I can just handle that, but maybe I don't want to do that same behavior for a complex number or a real numeric number. So you can customize the code based on what the type of the arguments are. Hopefully that answers some of your, something like that. Sometimes use one, for example, you can declare a collection to be an integer that will use less memory. That's one example. And same for operations. For example, if you want to do some addings or multiplying, you might, if you use integer numbers, you might hit an error like overflow that will give you the wrong number because the number that you're trying to represent, it's bigger than the maximum number that it's, or integer that's allowed for that data type. So maybe you should treat them or convert them as cast, maybe as numeric, and then do the operations, and then that way you the precision or allow for not triggering Here, second, what I'm doing is based on the teddy bear syntax, we'll be using quotes, and quotes are inside or escape. That means that you use a left or a backslash and then the quote. That's to escape it. R still doesn't like emojis. I tested this with R 4.0, tried to put some emojis, and it didn't work well. Julia does, because it supports Unicode. And here I'm like my name in Chinese. So you can use strdetect, which is from the stringr package. And it takes the string. Is everyone okay? And a pattern. So basically what it's doing is it's looking for this pattern, Bayoán, which is here. And it's saying, yes, I detected that pattern in that string. I can, if I pass a pattern that does not occur, then it will return false. I can extract substrings by passing the string and then some pattern. Here I'm using brackets which there will be a training on that. I can also use str sub, which basically takes, let's see, 28. Actually, I'm not sure, but basically you just pass the start and an endpoint, and it will choose the character. For example, this would be the first character, second character, third character, and you can substring based on that. You can also replace. So here I have a string, I have a pattern, and this should be the replacement. So it will change whatever that pattern is, which is everything that comes after that, and just replace it with me. Or you can just remove, replace not the first instance, but every instance, and concatenate. So here, what I'm doing is I am putting this string first, and then this value, and I'm joining them with the separator of its space. So these are basic operations that you can perform with the character data type. Any questions on that? We good? Let me just double check. Aaron, can you put in the chat how much time I have, just to keep track of that? Thanks. So now we'll go over collections. So collections are different structures that are composite because they are collections, basically, because they're arrays. Perfect. And vectors in R have the same data type for every element. That means that you cannot have a vector with characters and numbers, because the idea is that the same vector has the same data type. So in this case, I'm defining a vector with a Boolean, which is called logical mode, of length 2. So now I have a vector, and it will default to using the value, or false value. Same for a character. I will use the empty string for numeric and integer. Okay. So here I'm doing a range. That means that I am passing a vector that takes the natural numbers, because it starts at 1, ends at 10, and the default step is 1. So we'll show 1, 2, 3, 4, 5, 6, 7, all the way to 10. And I can use the str function to get basically a representation of the object. So you can call str on an object, and we'll tell you a little bit of what the data type or some properties of it. I can also pass the summary function, and based on the object, it will give me some summary of it. So for example, here, this is a vector of integers. And if I pass summary, it will give me summary statistics. I can use the table. And yeah, the table, what it does, it gives you the values and how many times they occur. So it's a frequency table. I can also replace values. So here, what I'm saying is I'm going to replace all the values of x in the position 2 to 5. So x2, x3, x3, x4, x5 with the value 1. And when I look at that, I see that they have all been converted to 1. So this is how you can replace elements of a vector. If I assign a value that's outside the length of the object, what R does is, well, it will do a few things. One, it will dynamically change the length of the vector to match whatever position of, like the biggest position of the value that you have assigned dynamically. And it will also either convert the value that you're assigning it to the data type of that vector, if possible. If it can't, then it will change the data type for all the values in the vector to match or to be able to handle that type. That's might be convenient, but it's also really dangerous. So if you have a vector of 1,000,000 integers, and for some reason you put a value there that's like a text, it will change all the data types of those and allocate a new object with all of them as a character. So it's convenient, but also dangerous. So just keep that in mind. You can also sort a collection. So here I'm sorting the values. I'm saying I am one of for handling, and I said that's the minimum value. Here is what I was saying just before. I am expanding the vector and adding a data type that's different. So it couldn't convert that into a number. So what it did is it created a new object allocated of that length and based on the union or the promotion of the types in order to handle all of those. And you can check whether it's a vector. Any questions so far on vectors? Okay. Now we have matrices. Matrices are really similar to vectors, but they're two-dimensional instead of one-dimensional. And when you create operations in R, I have x times x, it won't make a matrix multiplication or something like that. It will just add each element or multiply each element. So it's the cron operator. So everything will work element-wise. I can take the transpose of the matrix, and then this operator is actually matrix multiplication. So that's something if you're coming from MATLAB or other languages, just to so you know that in R, these are element-wise, and there are different operators if you want to operate at the matrix level. Yes, so a vector would be a single column. Exactly, just one-dimensional. A matrix will be two-dimensional, so that would be like a spreadsheet. And the next one, you can also do summaries, tables, replace values where you pass the row, then the column, and keep doing that for each dimension. And here you have arrays, which are multi-dimensional collections. So if a vector is one-dimensional, matrices are two-dimensional, array can be arbitrary dimensions. So here, this is a three-dimensional array, which is dimensions 2 columns, 4 rows, and the third dimension, 3 dimensions. Then to get the columns by rows, and then each dimensional or higher dimension there. These are what allows you to have collections of different data types. So these are heterogeneous collections. And I can use the dollar sign here to get that attribute or get that element. So here there's a list and it has a name or a way to access that element. So it's here. I can also change those with the assignment, same way as before. I can select, and if I select a list, just like that, it will give me basically the key and the value. If I want the values, I use double brackets. This is something really confusing for people that are learning R at first. Why do I put the dimension names or the argument names? So here, it's the same if I don't put the x equals and the y equals and the c and all that, that's completely fine. Or actually here it matters because I'm passing the names, but here, for example, I can just not have the data. That's part of the style that I use because I feel it's a lot easier to read code if the arguments are named. So I know exactly what the arguments are. It is not needed for the computers, but for the users that are reading code, it helps. Hopefully that answers your question. And you can also have nested lists like here. Okay. Lastly, we have structs. And a struct is rather than a container of elements, it's a composite structure. That means that it will hold different values of different data types, and it will define the behavior that you want for those. So for example, if I use now, it will give me the date time for that time in my time zone, local time zone. So what is a date time? A date time basically is the number of seconds or milliseconds in some arbitrary date. That's usually like the Unix epoch or an epoch. And based on that, it will give me the instance right now, which for example, it's 2020, say June 5th, 1323, like Puerto Rico time, let's say. And then I can access the attribute values by some accessor function. So for example, I'm getting the year, the month, the day, the hour, the minute, the second. I can also get a representation of the whole time period in seconds. And I can also make some arithmetic for that data type. So if I add 1 minute plus 1 hour, how should that be handled? That's why the methods or the dispatch matters. Because if I'm adding up seconds and minutes, I first have to convert them into seconds, and then I can add them up. So the way that that's why data types matter. For example, this is giving me the time there. We can also get the names. And lastly, we're going to introduce something for pseudo randoms. So here I'm setting the seed, which is for reproducible purposes. I'm creating a factor, which is a vector that is an efficient and nice implementation of a vector that has few unique values and many. And I can access that. It will give me labels, basically. So here are the elements, unique values, and I can use that to, for example, create here is a histogram where I have each of the categories and the count, and all of these were using or sampled from pseudo random distribution, or yeah, okay. Actually a categorical, but they were sampling. All right, I'll run out of time. I'm just gonna go quickly to the next step, if that allows me. Here we go. Let me just go to Git, PD, training, or basics. This one is really short. I'm gonna do the same thing. So here for dates, you might have a different lesson, but I'm just expressing a way of converting or casting different types. So for example, here I'm passing a string, and based on that string, I can construct a constructor function that gets me a date time. One of the arguments for that is the format. So for example, I can have a string like this, and it will parse and use some heuristics in order to find out what the proper representation in that data type should be, right? So for example, same here. So this is a same data set that we used for flights in a previous training. What I'm doing here is selecting some columns, which are here. Then I am modifying those. And here what I'm doing is I'm making date time. So I'm creating, instead of having year, month, day, hour, minute, I am creating the date time object. Yeah, so this is one way that you can create those. Here I'm using MATTR, which is basically a way of getting the efficiency of data table, but with a nice dplyr-like or piping framework. And Aaron will go over some of that. So if I have a non-standard date format, I can use some format style, which here is a reference, in order to get it into the way that I want it. Any questions on that? There is some, I just wanted to make a little note that when you're doing data arithmetic, not every day it's 24 hours. Just keep that in mind. So when you're, for many purposes, just doing the minus, for example, will give you the time difference, and that's good. Sometimes you want to create an interval first and then cast a period, just because of time zone changes and all that. So sure that when you're doing a arithmetic on some time, you understand representation well enough to not make mistakes. But you expected something. And that last material that which is this one here. Which is the functions and control flow. So functions are, everything should be a function basically. And the idea is that you want some behavior or algorithm that you have implemented, and it's generalizable, that it takes some arguments and it gives you some output. That's it's good practice to have everything as functions for keeping your code organized, as well as having better performance. So here it's a short example. I'll go over some of it, not everything. But the idea is there are multiple ways to get the same functionality. For example, the factorial function is a classic example in Intro to CS, where basically you define a function, takes an n, which is a natural number. And if it is a natural number, this is what it means. Dividing by 1 and making sure that it's an integer, and that the integer is positive. If it is 0 or 1, it just returns 1, because that's how the factorial is defined. If it is not, then it's, the factorial is defined as that value times the factorial of the value minus 1. And this is for natural numbers. So that's one way that I can define the function. And I can test it. So whenever you're developing code, it's good to add a test to the whatever capacity you can. So you know that whatever you're expecting the code to do is actually doing that and not something else. So you can use the expect equal to make sure that, basically here I'm just using the factorial base function versus mine, and they match. And what I'm doing here is a recursive function that's using if and else statements, which is basically the function throws that at the chat. And would we want to do this or use it for our source? Yeah. So for example, for those that are developing Shiny apps, you should have those the functions. So when a user toggles something and say, I want to filter out only these rows, then your function can take a different data set and then plot whatever, or render a plot that only uses that data set. So if you hard code the code, then it won't work in the way that you want it. So if it is a function and you're developing a Shiny app, then the user can modify, change the arguments, and then you get the functionality generalized enough that it can be used. Hopefully that answers your questions. If not, feel free to interrupt me. The other way to use control flow is by using if, else, but there's also a while loop. So a while loop basically keeps doing this infinitely until you break out of it. So that's another way that you can control the flow of a function. The stop, basically, these are argument validation statements. So if you're doing that, it's good that you verify that the arguments make sense. If not, throw an error that's clear for the users or someone that's running the code, or maybe you 2 weeks from now, let's say, oh, this is why, because it's supposed to be a positive number, not a negative. That's why. So here is a while statement. Okay. In R, sometimes we have the for loops in like I, in, and then the collection. You can use these basically more descriptive names. So you could say for slug, in slugs, where you have the singular and then the plural. That just makes it nicer for reading the code. Okay. This is an example from Exercism.io, which is another resource. It's free if you want, or especially if you're learning R. Has tons of good examples. Same with like data camp. Use whatever resources you are most effective for you to learn. Okay, I just have it there. One last point that I want to make with R is quite slow. It's not great. And the way that R gets some performance, or the biggest boost in performance, is that it will just call C code. But based on how the language has been designed and was created, in order for R to do that, it has to be vectorized code. So that means that it will take some code in R, and before it runs it, what it will actually do is convert the R code into C code and then execute it in C. That's, for example, the approach that data table does. So here, I'm just demonstrating that. So here I have a vector, goes 1 through, I think that's 1,000,000. And I'm just taking I'm squaring each element. Because that's vectorized, it literally takes nothing. If I have the same code, but as a for loop, which is not vectorized, that's why you should avoid for loops like the plague in R. You will see that even for pretty simple code, it's quite noticeable. Likewise, I am going over the last point that I want to make. Here I'm just loading the iris dataset, which is about flowers. And here I am doing something called pre-allocating. So when you're iterating, or you know that there's going to be some output, or maybe you know the data type of the output and the length, what you can do is you can pre-allocate an object and just fill in the values as you're computing like the values in the function. So here I'm not doing that. I'm just creating, oh, this is a list, but I'm not giving it the exact length. So every time that this is running, it's expanding that list dynamically, which is not great. It's convenient, but it's not great. Here, I'm doing it a little bit better. I'm creating data function that takes some data. And here I'm just filtering all the species that are Setosa, right? What I'm doing here is I'm copying X, which is here. So basically, I am pre-allocating, but the right length. So that means that I'm not dynamically changing the length of the container. It has already been pre-allocated. And what I do is, in the for loop, I compute the value and assign it directly. So this is a better way of doing the code. Another way that you can do it is using functions like doCall, where you have a function, then so here what I'm doing is I want to combine the output afterwards. So I have a list of data frames and I want to combine them with rbind there, and lastly I get the full data frame, which is just 10 times the same data, which are only observations in Setosa. So this is only to showcase some of the ideas. A better way of doing it is through tidyverse. And tidyverse has a package called purr, which is like cats and whatnot. And you pass basically a map, which means you're going to go and do this as a loop, basically, but as an efficient way. And you can actually declare the or basically what you want the output to look like. So here I'm saying I want the output to be a data frame. I'm passing the arguments as a vector or a collection, and then the magic. So this will do all of this of creating a data frame or the list and combining them and pre-allocating all that just with a nice syntax, and it's more efficient. So that's basically the idea. If you are going to allocate, for example, create or do some iterations on an element and then combine them, what you probably want to do is take a look at the per package, because that way it will give you a nice way of using functions, passing an interval or a collection, and then getting the output in a nice way that is efficient. This is just an example of the two approaches. And yeah, so that's what I wanted to go over. And let me just double check here. Any questions so far? I believe that's 15, that's half an hour. Yeah, so we have a few minutes. No other questions. I will just mention it, might be in a different session, but we do have a debug feature on RStudio. So for example, if I have a, say, magic is a function, this is the way that you define a function, and the arguments, I'm gonna say this is gonna be the number. I'm just gonna add it a default to be 5. Gonna define that. I'm just gonna take the square root of num. Right. So if I do magic by itself, I'll just give me the square root of 5. I can do magic and pass, let's say, 4. And I'll give me a square root of that.
I think that we're no longer seeing your screen.
I can put it as an integer. Oh, wait. Oh, thank you. Sorry. Thank you, brave person. Okay, here. Can you all see it now? Perfect. Sorry about that. So this is the way that you define a function. So I assign magic, which is the name of the function, a function that takes an argument, which I have named num, and I have passed a default value. I have defined the function here, which is takes the square root of that, and let's say adds 1. Here I don't need it, I just put it because I like it, doesn't matter. Actually, I'm just gonna I can replace that. So if I pass magic, it will give me the square root of 5 plus 1, because it's called with the default values. If I pass 4, it will give me square root of that, which is 2 plus 1, will be 3. That's what we have here. But if I do the negative of that, and I call it, I get a warning message and all that. So one way of here, it's a warning, that's not an error. So it's good to know basically the different levels of communication. So you can give a message, that's just information. You can give a warning, which doesn't give an error, but it's data warning. So do pay attention and make sure that it makes sense. If it is an error, for example, I am, let me see, I am gonna try to do the num plus a character. That's gonna give me an error because you cannot have a non-numeric argument to binary operators. Say that I'm printing X, and I'm going to add a breaking point there. So when I run that, I need to start the debugger. I think we're gonna have a different breaking code. Let's see when the size, okay, here. All right, I'll do a separate version for debugging just because I didn't think that we were gonna have enough time, and yeah, I was correct. All right, any questions before I turn it to Aaron? It's gonna go over data frames and data tables and tables and all that. Good. Was it useful? All good? Perfect. All right. Hopefully that helps. And if you have questions, you have all the materials there that you can go back, and feel free to reach out. And hopefully, if something doesn't make sense now, it will eventually, and you'll be like, oh yeah, that was useful. So, right, Aaron.